Oke, baik. Kita mulai. Sebentar, saya izin untuk share screen. Baik, selamat malam semuanya. Hari ini kita minggu ke-8, hari yang kedua. Tapi yang beda di minggu ke-8 ini kita bahas tentang 2 materi yang berbeda gitu ya. Jadi kemarin kita udah bahas structuring machine learning model. Kalau sehari ini kita akan bahas mengenai browser-based model with TensorFlow.js. Oke, kita next. Hari ini agendanya kita itu adalah intro to TensorFlow.js dan image classification in browser. Oke, apakah semuanya sudah siap? Oke, kita next. Oke, sedikit recap. Mungkin ada yang mau sedikit recap tentang materi hari Selasa kemarin. Kita belajar mengenai structuring machine learning model. Kemarin kita udah belajar code-nya itu tentang supervised learning dan kita belajar mengenai regression gitu ya. Oke, hari ini kita akan membahas mengenai TensorFlow.js, intro to TensorFlow.js. Nah, apa sih TensorFlow.js itu? Jadi di sini TensorFlow.js adalah library machine learning Google untuk JavaScript. Dan itu seperti versi asli dari TensorFlow yang keluar dengan Python. Tapi ditujukan untuk orang yang membuat kode dalam JavaScript atau Node.js sebagai gantinya. Jadi kalau orang nggak bisa Python, nggak bisa itu, jadi dia bisa ngelakuin TensorFlow itu di JavaScript atau di Node.js. Itu. Oke. Materi hari ini itu cukup sedikit karena materi pembelajarannya cuma 2 slide. Jadi slide ini dan yang satunya hanya slide untuk kita nonton gitu. Nah, nanti untuk yang image classification in browser kita akan demoin ya. Oke. Jadi di awal kita bakalan nonton ini dulu. Setelah itu baru kita akan lanjut ke demonya. Nah, aku mau tanya dulu nih sebelumnya. Kalau kayak gini nih, ketutupan nggak ya layarku? Kalau aku kecilin gitu. Ketutupan ada hitamnya gitu nggak? Oh, enggak. Oke. Kalau enggak. Oke, kalau gitu kita bakal nonton dulu. Butuh subtitle nggak nih, teman-teman? Aku pakai subtitle ya? Atau enggak? Oke, sebentar aku share sound. Oke, aku jaga-jaga pakai subtitle aja ya mungkin yang nanti. Oke, ini aku mulai ya.
Stay tuned for that. If you've got any pre-show questions, we've got another 1 minute. Feel free to ask before we kick off. Will JavaScript beat Python with machine learning? Is that the plan? Well, hopefully you'll see from this presentation what is possible. I don't think, I'm not promoting one over the other. So use whatever you're comfortable with. They're both very powerful. And I hope today's session will show you how far JavaScript has come in terms of machine learning as well. And especially for hackathons, it can be a really useful language to use in your toolkit. Cool, I'll be going into these questions very shortly. So I see someone talking about how I got into machine learning, my background. I get asked this a lot when I'm presenting. So my first slide will cover a very brief 1-minute background of my life career history to date to kind of go into that. All right, so I think it is time. So I'm going to go ahead and share my screen and get this party started. So hopefully you can all see me okay, and feel free to double click on whoever is talking to make us full screen if you want to zoom in at any point. Can everyone see the slides? Just a quick show of yeses in the chat if you can see the slides. Awesome, good stuff. All right, so welcome everyone to the TensorFlow.js talk. Of course, we're going to be talking about supercharging your prototypes using machine learning in JavaScript. I am Jason Mays, developer relations engineer for TensorFlow.js here at Google, but currently live from my bedroom. And I'm also joined by Chevy, who will be taking the second half of the talk. Now, as I mentioned, I do get asked a little bit about my career history, how I got into this role at Google, and I'm just going to go quickly over that. So I started as a computer scientist at the University of Bristol over in England. Yes, I'm from the UK, hence the accent, and I studied many things there and specialized in reality mining, pseudo-anonymous social networking, and the next generation of mobile devices, which is the current generation of smartphones these days. And I then kind of focused on web engineering when I joined various startups after I graduated, including founding my own as well. And it was there I realized that I kind of enjoyed both sides of the coin, being technical and creative. And that's when I became a full stack web engineer, doing both front-end design, UX engineering, and even like photography and other things as well, combined with the programming stuff all in one job title. And that allowed me to prototype anything I wanted. And I joined Google as a web engineer shortly after, and progressed on to becoming a creative engineer or creative technologist. What this allowed me to do was to create prototypes for Google's top 100 or 150 customers globally to try and use emerging technologies, things like machine learning, augmented reality, virtual reality, projection mapping, all this kind of stuff, to come up with like world first to help tell their story in a novel way. And that's where I really kind of went wide and tried to explore many areas. But I realized my passions were, of course, web engineering and machine learning. Those are my favorite areas. And that's why I became developer advocate of TensorFlow.js just over 1 year ago. And if there's one kind of thing that you take away from this slide, is that I've basically been tinkering with JavaScript for 16 years of my life. And I'd like to share the reasons why you should consider using JavaScript as well for hackathons and, of course, for machine learning. So let's get started. Now, I know everyone's from very different backgrounds, so I'm going to give you the 101 on machine learning as well. And the first thing to state is that machine learning really could influence every industry out there. And this is a really exciting time to be alive. Already we're seeing many industries starting to use machine learning, but looking towards the future, this could grow even more so. In fact, we could be close to the beginning of a new age. We've already gone through various revolutions in the past, the Industrial Revolution, the scientific and digital revolution, which are currently in. And my personal prediction is that the machine learning revolution, if we're not already in it already, is not too far down the line. And the key thing to take away from this graph is that in that next step that we're going to take, we might make more human progress in terms of innovation than we have done in the entire history of our species. So it's a very exciting time to be alive and to start playing with these technologies right now. It's very rare in your life you get a chance to start with something at its infancy like we are having right now. But what's the difference between all these buzzwords you might be hearing? Artificial intelligence, machine learning, deep learning. I'm sure many of you have heard these words before, but let's just dive into those to make sure everyone's on a level playing field. So first of all, artificial intelligence, or AI, is essentially the science of making things smart. Human intelligence exhibited by machines. Now, this is a very broad term, and actually, we're currently in a scope where we actually make programs that are around narrow AI. And all this means that we make systems that can do one or a few things as well or better than our human counterparts can do in very niche areas, such as recognizing objects. And a great example of that is in the medical industry, where doctors use AI systems to look at brain scans to find tumors. And because these are very grainy images coming back from the various machines they're using, it can be quite hard for the human to tell what is a tumor and what is not. But with these AI systems, it can actually help them find it much faster and identify areas earlier on, which is very good for patient and doctor. Now, machine learning, on the other hand, or ML for short, is essentially an approach to achieve artificial intelligence through systems that can learn from experience to find patterns in a set of data. So this is actually at the implementation level, if you will. This is the actual program that's doing the work. And the key part about these systems is that they can be reused and trained with new data using the same code base. Okay, now that's very powerful. And if we go back to the old days when I was programming, in traditional programming, if you're trying to make a spam filter, you might have a bunch of conditional if statements. If the email contains a certain word, mark it as spam. If it contains a different word, mark it as spam, and so on and so forth. So kind of like a list of words that are banned. Now, of course, the spammer gets savvier. Spammer. Fast forward to today, we can now use machine learning to essentially try and classify emails that have been marked as spam automatically, and it tries to change itself to reduce the number of errors it does in prediction, and it learns to associate words that come up frequently with spam automatically. So we don't have to maintain those lists ourselves as engineers, freeing us up to do other things that are much more useful. And there's many different use cases for machine learning out there, things like computer vision, such as object detection, recognizing objects in an image, or numerical regression, such as predicting an output value from an input value. So for example, what's the price of a house given its square footage? With enough training data, you can actually predict that. Or how about natural language, to understand the sentiment of a piece of human text to see if it's positive or negative, or if something is toxic or not. We've also got speech recognition for the audio side of things. Anyone with a smartphone these days takes it for granted, but this is all powered by machine learning behind the scenes. And my personal favorite is generative stuff, style transfer and creative applications. And you can see some fairly recent research from NVIDIA that came out not too long ago on the right-hand side. And the key thing to note here is that all of these faces do not exist in the real world. These have been dreamt up, if you will, by the machine learning system, and it's been trained on a bunch of celebrities' images. That's why they all look kind of like celebrity-ish. And it's working the same way. If I ask you to think of a purple cat right now, you could probably do so even though you've never seen one. You've learned the essence of what a cat is, and you can kind of change it to be purple in your head. And this is a similar kind of process that's going on here once the machine learning has learnt what the essence of a face actually is. And then deep learning, on the other hand, is essentially a technique for implementing the machine learning we spoke about on the previous slide. This is one of the algorithms you can use in the implementation, which is the machine learning program on the previous slide, that you can choose from. And there's many others out there too. Now, one such deep learning technique is deep neural networks. And essentially, this is where the code structures that you're writing are arranged in layers that loosely mimic the human brain, essentially learning patterns of patterns. And what do I mean by patterns of patterns? Well, you can imagine in the first layer, it could be learning something very simple, like how to spot lines in an image. And then if you go one layer deeper, those lines can combine so that you can recognize shapes, maybe like squares or triangles and things like this. And we go one level deeper still, and those shapes can combine to then recognize features such as a face. A face might consist of two circular kind of looking things here, a triangular thing here, and an oval looking thing here. And when those things are combined in a certain way with a certain distance between them, you might be able to then recognize that a face is in the image, okay? And that's kind of the kind of underlying concept that's going on here in this network of layers. So the key thing to take away here is that these three terms are interlinked. The deep learning is one of the algorithms you can use to make a machine learning program, which is the implementation. And this can give us this grand illusion of artificial intelligence, which is kind of like the holy grail of what we're aiming for. And these concepts have actually gone back to the 1950s. In fact, they're not new ideas, but it's only now that we've got the processing power at cheap enough cost to be able to do so with the graphics cards and RAM and all that kind of stuff that's now available to us at high quantity in the cloud. Now, you might be wondering, how do we train these systems? And it's a great question. And for the purpose of this exercise, we're all going to pretend to be farmers. We've got apples and oranges, and we want to try and classify them so we can put them in the right boxes to send to the right places. Of course, you could apply this to other problems in your domain if it's more specific, but for now, we're going to use apples and oranges. Now, the first thing you need to figure out are what features and attributes can you identify that you can measure in some digital way, and numerically as well. So here we might choose something like weight and color. Both of these things can be used, measured using digital weighing scales or RGB camera or something like this. Now, once you've got these values, you take a sample, maybe 100 of apples and oranges, and you plot this on a scatter graph, and you might end up with a plot like this. You can see we've got color here on the x-axis and weight on the y-axis. Now, the apples, which are green, fall into the green spectrum on the color of the x-axis and have a slight variance of weight, and the same for the red apples. And then the oranges, because they're slightly more juicy, they're a little more heavier on average and they're slightly higher up. Now, if we were to draw a line that separates the apples from the oranges, we can then say with some level of confidence that anything above the line is probably an orange and anything below the line is probably an apple. And that's the essence of what machine learning is trying to do behind the scenes. Instead of a human drawing this line, we're getting the computer program to find out the equation of this line such that it can separate the data sets as much as possible. So when it sees a new item in the future, it can then determine which side of the line it falls to then classify it correctly. Now, this is a very simplified view of things. And if you implement this, this is probably stuff from the 1950s. Things have come a long way since then. But this is the essence of what's going on behind the scenes. Now, it's not always obvious what features and attributes to take. So let's pretend we chose ripeness and number of seeds for our fruits earlier. You might end up with a scatter plot like this. And you can see here, there's no easy way to separate this data, even with a curved line. And you might be, well, Jason, why would you choose such bad attributes? Obviously, this is not going to work out very well because these are very variable things. And yes, sure, for fruits, it's very obvious this is going to be a bad choice. But what about those brain tumors that we were talking about earlier? The features for those are pixels in an image. How do you define how to separate those out? That comes with a lot of practice and a lot of knowledge. And this is what essentially feature engineering is all about and is what people get paid a lot of money to do properly. And of course, what about higher dimensions? In our previous example, we had just 2 features or attributes. If we had 3, as you can see in this graph, we now have to use a 3D graph to separate the data instead of a 2D one. So you can see here, instead of using a line, we're using a plane or a rectangle in 3D space, if you will. And you can see that the oranges, the kind of grayed out orange circles, are behind the plane, and the apples, the red and green dots, are kind of in front of the plane here. Now that we've got the weight dimension, we're able to separate the data again. And it's important to note that machine learning actually works in dimensionality that's much higher than this. We could have tens, hundreds, thousands, even millions of dimensions in the case of images. Now, our brains as humans cannot visualize this, but you have to trust me that the mathematics is actually exactly the same, and the computer can do that mathematics. And instead of using a plane, you're using something called a hyperplane, which simply means one dimension less than the dimensions that you're working in, okay? And that's how it's able to separate the data up when you're doing more advanced machine learning. So it should be easy, right? We've got dogs, we've got mops. They look completely different. What could possibly go wrong? Well, it turns out that some dogs look like mops and vice versa. And my reason for actually saying this is that your biggest challenge when trying to make a machine learning model is finding enough unbiased training data in a format that the machine learning system can actually learn from. And imagine you wanted to recognize cats. Essentially, you would need maybe 10,000 example images of cats of different stages of their life cycles, different breeds, different colors, inside, outdoors, taken from different angles on different types of phones in different lighting conditions. All of these variables need to be taken into account to have the best chance of the program learning what cat pixels really consist of. And the other thing to note here is that data does not always have to be images. It could be tables of data, it could be text, it could be sensor readings and sound samples. I obviously use images in my presentations because it's easy to visualize, but remember, it could be other things too. So long as it can be represented numerically, then it can be used in a machine learning model. So why do we want to do machine learning in JavaScript then? And that is also a great question. Essentially, one of the advantages of JavaScript is that it can run in many different places, and that means we can run machine learning in all of those places too. The web browser, server-side, desktop, mobile, and even Internet of Things. And if we dive into each one of these stacks even further, you can see many of the technologies you may already be hacking with today. We've got the common web browsers on the left-hand side, Node.js for server-side, React Native for native applications, Electron for desktop native applications, and Raspberry Pi for Internet of Things. And this alone is a selling point for JavaScript. There's pretty much no other language that can run in all of these environments without additional plugins, add-ons, or conversions in order for that to work. So that's very powerful. And with TensorFlow.js, you can retrain via transfer learning or write your own machine learning models completely from scratch, just like you might already be doing in Python if you're already familiar with machine learning, but in JavaScript. And with that, you can make anything you might dream up, from augmented reality, sound recognition, sentiment analysis, conversational AI, and much, much more. So there's several ways you can use TensorFlow.js depending on your skill level in JavaScript, with machine learning, or both. So I'm going to go through some of those today. The first way and the easiest way is to use our pre-trained models. These are really easy to use JavaScript classes for common use cases. And we've got many of these available for you to use, such as object detection, body segmentation to understand what pixels on an image belong to human bodies, pose estimation, face mesh to understand points on a face, and much, much more. You can check out tensorflow.org/js/models to see all the ones that we have available for you today. But let's dive into some of these right now. Now, the first one I want to talk about is object recognition. This is using a model known as Coco SSD behind the scenes, which is a fancy name for the model architecture. We won't go into that right now, but essentially you can see what it can do. It can actually identify 90 common objects out of the box without you having to do anything, things like dogs, cats, tables, chairs, things that you might find in your everyday life. And it will tell you where in the image there are. And of course, if you know how many boxes there are, you can actually then count how many of those objects are too. So this is different to image recognition, which will tell you an object might be present, but it won't tell you how many or where. So this is a slightly more powerful version of that. So just to show you this in action, live on a web page, I'm going to switch over to my web browser, if I can bring it over. And this is over on glitch.com. If you just go to glitch.com and search TensorFlow.js, you'll find our page there, and you can try this demo yourself. But essentially, once the model is loaded, I can now click on any one of these images and get real-time classifications coming back of the objects it's found in there. You can see here how easy it would be to make something to detect if your dog is trying to eat the snacks in your kitchen whilst you're away, and send yourself an alert with some WebSockets or something like this. In a matter of hours, you can make a really powerful web application or your own home security camera. And on the subject of home security cameras, let's just prove to you that it does work in real time. Here I am live talking to you today, and you can see it's running very fast in my web browser as I'm speaking to you. And what's really cool here is that because this is all executing in JavaScript, this is not on the server side, other than the website itself is hosted on the server, but it's then executing in the web browser itself. None of these images are being sent to the server for classification, which means my privacy is preserved. My images are not being sent 1,000 miles to some server in another country for classification. It's all happening locally on my machine. And that's really important in today's world where privacy is top of mind. And with TensorFlow.js, you get that for free. So that's the first demo. Let's go back to the slides. One moment. All right. The second thing I want to show you is face mesh. This is just 3 megabytes in size, and it can recognize 468 facial landmarks, as you can see on the slide. And we're starting to see a number of businesses and other use cases come out using this kind of machine learning model. And on the right-hand side, you can see a demo by Modiface, who's part of a L'Oreal group, for augmented reality makeup try-on. The important thing to note here is that the lady in the right-hand image is not wearing any lipstick. We're actually using our face mesh model combined with WebGL shaders from the web industry to render lipstick onto her lips in real time, and she can change the shade at will. And it works super fast and fluid in the web browser, and now she can try on the makeup before even going to the shop or having to leave her house, which is really, really cool. And we're starting to see other applications like this come out as well, for like sunglasses and other things where people are getting, other things applied to the face in real time or around the face and that kind of stuff. So super fun, and a lot of fun potential with this model. So again, I just want to show you this in action. So if I bring over my live demo, here is a live demo of this. And you can see, once again, I'm live right here talking to you right now. And you can see the machine learning working on the left-hand side, and it's doing a good job of recognizing where my face is in 3D. But because this is JavaScript, not only are we doing the machine learning, we're using the rich visualization capabilities of JavaScript to render this 3D point cloud that I can move around in real time on the right as I'm speaking. And you can see me open and close my eyes and mouth and all this kind of stuff all in real time. I'm getting a solid 30 frames per second And I think it can go higher. It's just that my screen refresh rate is capped at 30 frames per second due to my dodgy cable I've got going from my computer right now. But basically, it works really well. And I encourage you to try this out and think how you might want to use this in your own applications. In the new version of the model, you can actually turn on predict irises. And this does use a bit more processing power, but you can now see more detail around my eyes as I blink and stuff like that, which might be useful if you need blink detection or things along those lines. All right, back to the presentation, and let me close that. Otherwise, I'm going to eat up all my processing power here. All right, good stuff. So back to the slides. The next one I want to talk about is body segmentation. This allows you to distinguish 24 body areas across multiple bodies all in real time, as shown by this illustration on the slide. And you can see here the different colors of the bodies represent different parts of the body. And even better, inside each of the bodies on the right, you can see these blue lines, which represents the estimation of where their skeleton is. And this is really useful to be able to make things like workout rep counters, which I know Chevet's actually already made. And we've seen a lot of people in the community do this for yoga kind of workouts and things like this to tell you how to do the pose correctly and that kind of stuff. So we're starting to see our community use these things for really interesting possibilities. And just to further iterate on this, here's a few more things that I've created using body segmentation myself. On the left-hand side, you can see me getting up on my bed and removing myself in real time, kind of producing this Harry Potter-like ghostly effect. You can see in the middle, the bed deforming, but my body is no longer there. And the key thing to note about this is that, I made this in less than 1 day, okay, using the pre-made body pics model we saw on the previous slide. So TensorFlow.js and the web technology stack out there is really great for prototyping things super fast, especially at things like hackathons, where time is limited and you just need to get a prototype working as fast as possible. And then on the right-hand side here, I don't know about you, but I'm terrible at knowing what clothing size I am. I buy my clothes like once a year, and I never know what size to buy, especially all the different brands have different ways of estimating their sizes. But now with this tool I created, I can just enter my height, I can take a front pose and a side pose, and then under 15 seconds, it can automatically select for me at checkout a small, medium, or large t-shirt. And it's accurate to within a centimeter or two, which is good enough for selecting a small, medium, or large. So, super fun. And again, I made this in just 2 days. So, get hacking with this stuff. There's a lot of potential here. Or you can go further and give yourself superpowers. Here's a member from our community who actually can shoot lasers from his eyes and mouth. And this is kind of a fun one. But you can imagine how you could use this for some kind of movie client or something like this. If you want to bring a movie character to life from a superhero movie, you could do so and make some fun, interactive, scalable experience that anyone on the web can enjoy and take a selfie and post to Instagram or whatever it is you want to do. So with TensorFlow.js and WebGL shaders, this kind of stuff is possible. Or you can combine with other web tech. Here we see someone from the community combining TensorFlow.js with WebGL and WebXR. WebXR is web mixed reality, meaning you can do mixed reality live in the web browser now without the need for any other apps. And what's cool here is that he's able to now scan from a magazine any body and bring that body into his physical world, as you can see here with this cool particular effect. And the key thing to note here is that this is running on a 2 to 3 year old Android device, and it's still got great performance. So I thought, why not stop there? If we add web real-time communication to the mix, which is another cool technology, which is how we're talking to you right now, of course, it's using WebRTC for these web apps. I can now segment myself from my bedroom in real time, transmit the segmentation to a mobile phone somewhere else in the world, and then place myself in that space as if I really was there. And for me, I made this because of COVID times. I wanted a more meaningful way to interact with my friends and family because I'm from England. This is a better way than just being stuck in a little rectangular box behind the screen. And people can walk up to me, walk around me, and kind of hear my voice from the right direction and that kind of stuff. So maybe in a presentation in the future, this is how I might present to you at some point in the future. Super exciting times. Now, the second way to use TensorFlow.js is via transfer learning. And essentially, this is about retraining existing models to work with your own custom data. Now, there's many ways to do this, including writing your own code completely from scratch, but I'm going to focus on 2 easier ways to get started for the sake of this presentation. Now, the first one is something called Teachable Machine. This is a website that allows you to retrain models live in your web browser and then export them and use on your own custom web page if you so desire. And the best way to show you this is with a demo, of course. So let's go ahead and launch that now. So if you go to teachablemachine.withgoogle.com, you'll be presented a page like this. At the moment, it supports 3 machine learning models: image recognition, audio recognition, and pose recognition. So today I'm going to walk through image, but feel free to go through the others in your own time. It's going to be the same kind of principle. So click on image project. And the first thing you're going to want to do is name the classes of the things you want to recognize. So the first thing I'm going to try to recognize is myself, Jason. And the second thing is going to be a deck of cards. So I'm going to call this cards for now. Now, allow access to your webcam and click on the webcam button, and you can now see a live preview from your webcam appear. So what I'm going to do is I'm going to try and get, I know, maybe 30, 40 frames captured by holding down this blue button and move my head around a little bit as well. I can't see how many I've done now. What does it say? 35 images. Okay, so I've got 35 images in my face. That should be good enough. And now I'm going to go down to the cards and do the same thing, but instead of my face, I'm going to hold the deck of cards up. And I'm going to try and get the same number of images and give it some variety as well. So let's move it around. I think that's similar. Is that 35? Oh, bang on, perfect. So you want to get roughly the same number of images in each class. Otherwise, there might be a bias thinking the other one's more likely to appear than the other. So you get as close as you can and then hit train model. Now, what's going to happen is live in the web browser, all in the web browser, no server is involved here. It's going to retrain the top layers of the model to learn how to classify and separate that data, kind of like we spoke about in the graphs previously. And you saw in just a few seconds, it's now finished, and it's giving us live predictions of the new model we just created. So in under 1 minute, we've made a custom machine learning model, and you can see it's predicting me, Jason, with 100% confidence. If I move in the deck of cards, you can see it's flipped the cards with 100% confidence. So Jason, cards, Jason, cards. And now we've made a model that can recognize my face or this deck of cards very, very easy, which is good enough for a prototype. Of course, if you wanted to be more robust, you need more training data. If I show it like a different rectangular object, it might get confused right now. So do be aware of biases when you're just prototyping like this. And for any production system, you need much more training data. But this allows you, at least for a hackathon, to prove a concept out very quickly. Now, if you like the model and its performance, you can click on Export Model here, and you can click on Download, and you can then simply download the files you need along with the code to run this on your own custom website. And with that, you can then add your own user interface and other things to make it cool and do something useful. We've even seen people take this kind of stuff and combine it with like Raspberry Pis and all this kind of thing to control their garage doors. So if you've left the garage door open and it's dark outside, it can automatically close the garage door or whatever you want to do. All of this is now possible. And remember, you can combine JavaScript to talk to other Internet of Things devices like Raspberry Pis. So you're not limited to just software. You can combine it with hardware activations as well. Now, Teachable Machine is super cool, as we just saw. However, if you want to do something more production quality, oh, 1 second. Can you still see my screen? I think you can. I think I just lost presenting 1 moment. Let's go back. However, if you want to make something that's production quality and you've got gigabytes of data for all the imagery you want to classify, then I'd recommend using Cloud AutoML, which supports exporting to TensorFlow.js. So here you can see someone trying to classify flowers. All they've done is uploaded loads of folders of different types of flowers to our cloud storage system, and then imported this into Cloud AutoML, as you see here. The next step, you simply specify if you want to have higher accuracy or faster prediction times. There's always a trade-off between these two things in machine learning. You set a budget, and it will go away and try and train on your training data to learn how to separate and classify those in the future. Now, it's going to try all the different hyperparameters. It's going to try different types of models to see which ones work best with your specific training data. And at the end of a few hours or maybe a few days, if you've got many, many gigabytes of data, it'll come back to you and give you a model you can export and download. And these files you can then save to your web server and host somewhere. And you might be wondering, well, how hard is it to use this kind of production quality machine learning? Is it any harder than what we've seen before? And the short answer is no. It fits on one slide. So let me just walk you through this code very quickly. At the top here, we just got some bread and butter HTML script tag imports. The first one is the TensorFlow.js library, and the second one is the Cloud AutoML library, just importing some JavaScript, nothing fancy. The third line here is just a HTML image tag of a new image you want to classify. In this case, I just grabbed a daisy.jpg from somewhere on the internet just to prove an idea here. Now, the actual code we need to write is in the script tag here. And in this function called run, you can see we call await.tf.automl.load image classification. This is the line of code we need to load the model.json file that we downloaded in the previous step after training. So hopefully this model.json file is stored somewhere on your web server, and we're just going to go ahead and pull that in, essentially using this line of code. And we use the await keyword because this is an asynchronous operation, meaning it takes some amount of time to do so. It might be a couple of megabytes in size for the model that you've produced. Now, once it's loaded, this will be assigned to the console called model, and we then move on to the next line. Now, the next line simply grabs a reference to the image we want to classify. This is a new image we've not seen before. So in this case, I'm just grabbing a reference to the DOM element from the web page where it had the ID of Daisy up above here. And this is assigned to the constant called image. Now, I'm using an image from the web page here, but this could be the webcam as well, remember. And then all we need to do is call await model.classify and pass the image you want to classify, and we wait for prediction to come back. And again, this might take a couple of milliseconds, which I know is very fast, but for a computer feels like a long time. So we still need to use the await keyword here too. And then this predictions object will just be a JSON object you can iterate through to find all of its predictions for objects it thinks it's seen in the image that you pass to it. And you can then, as a programmer, decide what to do with that information. If it's 80% sure it's seen something, you might be confident enough to do an action, or maybe you want it to be 90% sure. That's up to you as a programmer to decide what to do at that point. Now, of course, if you're using the webcam, you can just use model.classify again and again and again. You don't have to call load every time. Once the model is loaded, you just keep a reference to that variable there, and you can then just call model.classify again and again and again on the webcam data to get real-time classification. And that's all there is to it, all in one line. One slide. Now, the third way to use TensorFlow.js is to write your own code completely from scratch. That's for the more advanced users and is beyond this introduction talk that I'm giving right now. However, I'm going to focus on the superpowers and performance benefits of using TensorFlow.js and how it all comes together. So the first thing is an overview of the APIs that we have available to you. Essentially, there are two. We've got a high-level layers API, which is very similar to Keras, if you're familiar with the Python version of TensorFlow. And this is a nice high-level abstraction from the mathematical stuff, which is in the lower layers. Now, the lower-level API, as I mentioned, is called the Ops API and is the more mathematical version of this and more lower level. This allows you to manipulate things like the linear algebra and all this kind of stuff if you choose to do so, to make more high-level concepts for other people to use later on. And this comes together as follows. Essentially, we've got the models that we saw earlier in the presentation at the top here, which are built upon the Layers API. The Layers API sits upon the Core API. And then this can talk to different environments. And by this, I mean things like the client side. And on the client side, of course, we're talking about things like the web browser. Now, each one of these environments understands how to talk to different backends. And by backends, I mean hardware to execute on, such as the CPU. The CPU is always available, but is the slowest form of execution, but it's always there for you. We've also got WebGL, which is how we achieve graphics card acceleration in the web browser. It actually uses computer graphics to do mathematics, which is a really fancy hack, but it allows us to use the graphics cards to do this maths, and then we get very fast performance with WebGL. We also have WebAssembly, or WASM for short, which allows us to get faster performance on the CPU by leveraging more of the instructions available to us on the CPU. And nowadays, WASM is so good, it's actually on par with WebGL for performance for certain models in TensorFlow.js, especially the smaller ones, whereas WebGL tends to fare better with the larger ones, as there is an overhead of transferring data between the CPU and GPU continuously. And the same is true for the server side as well. Instead of using the web browser, you can use Node.js. And the cool thing about this is that Node.js has the same bindings as Python does to the CPU and GPU implementation. So it's got the same C++ bindings that Python talks to as well. And that means the inference speed of TensorFlow.js on the server side is as good or better, as we'll see, than Python for certain situations, for model inference, for example. And we'll get into that in just a few slides' time. Now, if you do prefer to use Python, maybe you're just more familiar with Python, that's completely fine too. But if you want to deploy to the web, you can actually take a Python-saved Keras model and use our Layers API within Node.js to then provide it to the world at scale in a nice web-friendly way. Or you can take the TensorFlow saved model without any kind of conversion, and again, use our core API to use within Node.js without any conversion and expose it to the web environment to get the reach and scale of the internet of all the people out there to use your model that you've created, which is super, super cool. Now, if you want to execute on the client side in the web browser and you've got a model in Python, then you have to take the saved model and use our command line TensorFlow.js converter to convert it to the model.json file that I spoke about previously and its associated binary files. And basically, these files can then be hosted on a web server and digested by a web browser and used in a similar way to how I showed you how you could use the Cloud AutoML Vision API. So super cool stuff, but let's look into performance. So here we can see Python and TensorFlow.js on Node for MobileNet v2, which is basically an image classification model. And you can see on the GPU, it's pretty much the same. It's within margin of error. It's less than 1 millisecond of difference. This is within margin of error, whatever the server was doing at the time when we tried to make these recordings. And the key thing here is that if you have a lot of pre or post processing, then if you convert that pre and post processing to Node.js, then you'll get the benefits of a just-in-time compiler of JavaScript at runtime, which can be significantly faster than the Python equivalent. And for those of you new to machine learning, the pre and post processing is just referring to the stage of manipulating your data from maybe the webcam sensor or the microphone to put it into a format that can be fed into the model. Because remember, you have to pass the model the data in a certain way. Typically, it has to be numerical, for example. And for TensorFlow, it has to be in the form of a tensor, which we'll get into later on. But basically, that's something to be aware of. And we can see here that if you do go ahead and convert your pre and post processing, these are the kind of results you can get. So Hugging Face, who are very famous for natural language processing, converted their Distill-BERT model into Node.js using TensorFlow.js. And they saw a 2 times performance boost over Python just by doing that conversion. So if you are interested in speed and optimizations where a 2 times boost could be useful to you for a certain model for end-to-end performance, not just the inference, the end-to-end performance, including the pre and post processing, then this could be of interest to you and of course allow you to deploy at scale to everyone out there who might be using a web page, which is pretty awesome. And then, of course, I want to end here with some of the superpowers you can get by using TensorFlow.js in these different environments. So the first thing is privacy. So on the client side, in the web browser, none of the data is being sent to the server for classification or inference, as we call it. And that's really important if you're writing a medical application or a legal application, or maybe you live in a country with strict rules like the GDPR rules over in Europe. Maybe you're not allowed to transfer the data to a third-party server from the client. And in that case, you get it for free with TensorFlow.js. The second point is lower latency. Because you're not talking to a server, you don't have to send the data from the webcam from the client to the server and then wait for the result and then get it sent back to the client again. All of that round-trip time disappears. The third point is lower cost. Because you don't have a server running inference 24/7 with costly graphics cards and the lots of RAM, you can remove the cost for those expensive servers as well. And then the fourth point, interactivity. JavaScript from day one has been designed for the presentation and display of information, and it's been around for a long time. So our libraries in JavaScript are super mature, things like 3.js for 3D graphics, data visualization, and much, much more. So there's a huge community around this, which allows you to hack super fast too. And then the fifth point is reach and scale. Anyone in the world can use a TensorFlow.js application if it's deployed to a web page. We just go to the web link and it just works. There's no requirement to understand Linux. There's no requirement to install TensorFlow, install Python, install the CUDA drivers, clone a GitHub repository, and then understand the README for all the requirements. You can just share it with a friend and let them try it out, which is much more powerful if you want to have some kind of viral kind of sharing going on for the thing that you've created, and get others to try the model, and so on and so forth. Now, the same is true on the server side as well. There's some benefits of running TensorFlow.js on the server side instead of the client side. The first thing is that you can use TensorFlow saved models without conversion. So if you prefer to use Python, that's completely fine. And you can still use your saved models from that without any conversion in Node.js. You can also run larger models than you can on the client side. If you're running a very, very beastie model, which is like gigabytes in size, obviously it's not wise to push that down to a tiny mobile phone to execute on. It'll take a long time and maybe run out of memory. So running on the server gives you that consistency if you need to do so. Third point, it allows you to code in one language. And if you're already using JavaScript, that's a really powerful point. Currently, 67.8% of people in the world use JavaScript as one of their primary development languages in production. That's a lot of people. So if you are one of those people, then it can help you stick to one language, which is very, very powerful. Fourth point, large NPM ecosystem, lots of modules and libraries to help you manipulate data and so on and so forth to get things in the right form. And of course, the fifth point, the performance benefits. We have the same C bindings as TensorFlow Python, so the same inference speed as TensorFlow Python, but you do get the just-in-time compiler boost of JavaScript for the pre and post-processing layers, which Python does not have. So to end this, some resources. If there's one slide you want to bookmark, let it be this one. Take a screenshot of this one. Our website is tensorflow.org/JS. And we also have a models repository here and our GitHub code, as we are completely open sourced. There's a Google group if you have technical questions, and I've got some boilerplate code on CodePen and Glitch. And there's even a deep learning book called Deep Learning with JavaScript, which is written by folk on my team. And the only thing left to say here is come join the community. There's a Made with TFJS hashtag that you probably saw in my backpack earlier. Check it out on Twitter and LinkedIn and get inspired by what people are making. There's just not enough time to go through all of it here in one presentation today. And the only question left to ask is, what will you make? I leave you this final piece of inspiration from a guy in Tokyo, Japan, who's actually a dancer by day, but has used TensorFlow.js to make this really cool hip-hop video. And my point with showing you this is that machine learning really is for everyone now. No matter, it's not just limited to engineers and scientists, anyone, no matter what your background, creatives, artists, musicians, all have a chance to use machine learning. And I'm really excited to see how TensorFlow.js can help you achieve that. And if you make something, use the hashtag so we can find it and help promote it for you. So with that, stay in touch with me. I'm at Jason_Mays on Twitter and also on LinkedIn. And I'll hand over to Shive for the second part of the talk for some live coding. Thank you.
All right. Thank you so much, Jason. I'll quickly just share my screen and hopefully it should be visible now. Let me see. All right. So just to again give a very short introduction, Jason just spoke about what are the superpowers that you can gain with TensorFlow.js. So keeping that in mind, I'm going to be showing you a very short demo on the Coco SSD model that Jason also showed you, right? So just to again give a very short introduction about the Coco SSD model, the Coco SSD is exclusively being used for object detection, and currently it supports up to 80 to 90 different classes. Now, if you just look at this code, you can see that we have simply just loaded the CDN for TensorFlow.js and the Coco SSD model by using these two scripts over here. In the third one, you can see that we have just included an image ID with the image of that of a cat. And in the script, you can see that basically first, with using our JavaScript function of document.getElementById, we get our image tag, and then we use the CocoSSD.load, which will actually load the model on the browser. And this is the Coco SSD model. And over here, we basically use the .detect function to actually detect what is exactly in the image, and image that being of a cat. And then we console log the predictions that we get with our Coco SSD. And this is how, like, an example of it actually looks like. So whenever you use the Coco SSD model, you would see this bounding box. So bounding box is a way of actually annotating your image data, and it also shows you the label that we have. And specifically in this presentation and in this demo that I'll be showing, we'll be creating, we'll be basically uploading an image onto our website, and then we'll be creating an annotation similarly to how we are seeing over here, and it will make a prediction of what exactly is the image all about. And finally, I would like to share a few links of the CDNs. These are the CDN links that would be required for our work, right? Now, I will just copy these two links that are specifically taking into account the TensorFlow.js and the Coco SSD models that will be used for our presentation and for the demo that we have made. Now, I had already shared this boilerplate code with everyone. This is specifically the boilerplate code for the front end, that is the HTML and the CSS, that will basically show an very simple website like this, which has just an logo, and it just has a button that will be used to upload an image. Now, I'll be writing the actual code for the JavaScript, or the actual logic behind the JavaScript for this particular functionality. So quickly jumping onto the VS Code, right? This is my HTML file that I have. Now, if you quickly just go through this, I have included a few buttons. So one is a button for actually uploading an image, and I have put a canvas area, which is where our image that will be loaded and the bounding box that will be loaded along with what kind of prediction is being made on that image will actually come over here in this canvas. We'll be talking about like how exactly it is being used. And as you can see, this is where I have also have an input. This is where I'm inputting a file. So in this scenario, we'll be inputting an image, right? We'll be inputting an image file that will be using for detection or for the object detection. So over here, the first thing that I've already said is that we'll be just quickly adding our CDN links. So I've added the CDN link for TensorFlow.js, and I've added the CDN link for the Coco SSD. And since we are writing JavaScript code, I will quickly just add the link for this index.js file that I've created. I will quickly just add over here the script tag, and I'll add the source as index.js, and I will close this quickly. And then now we will officially get started by writing our JavaScript code. So the first thing, if you recall, that we saw in this particular demo was that we have to actually load our Coco SSD model. So the first thing that we'll do is actually loading our model into our browser, because whenever you are using TensorFlow.js, whichever model, for example, like the Coco SSD model is a pre-built model. So we are loading that model into our browser. So first we'll just define, let's say, a variable by the name of model, and then we will be basically calling our Coco SSD model that we have. So basically, it's Coco SSD is coming from that CDN link that you gave for the TensorFlow JS model. So basically, we have the load function that is pre-built to the Coco SSD model, and then we are basically using a promise that we are having. So if it is able to successfully load, it will give us an alert that, hey, your model is ready to be used, because normally it does take a few seconds to actually load. So simply what we'll do is that we will use this .then, and we will add, for example, a function that will get a response, right? So basically it will get a response, and the response that we would get is that in case the model is successfully loaded, right, the response is the model itself. So we are adding the model, and we are basically equating it to the response that we get. The response is the actual model, and let's say we'll get an alert to the browser itself that, hey, the model was successfully loaded. So let's say we can add the model is ready, right? The model is ready to be loaded, because this is an important step whenever you want to load any kind of a machine learning model in your JavaScript, right? So this is the first part, but this is not the only thing that we need to do. We can also add, let's say, a function which will say that, hey, like, the machine learning model did not load successfully. So what we are going to do over here is that we'll simply just add, or we can simply just add a console.log statement that, hey, the model did not load, right? The model did not load. So this is just to sort of keep in mind that, hey, for example, if the model for some reason your internet connection gets lost, or for some kind of another kind of an error, for some reason the model does not load, then you can add this simply, right? So this is the code that we'll write to basically load our Coco SSD model. Now the next step, basically, once your Coco SSD model successfully loads, we are going to be basically calling this function that I've already provided, that is invoke upload image. So basically, you want to click this function to upload an image, right? We want to upload an image. So we'll quickly just use the same function. I will quickly copy this over. So we'll define this function. So what this function will do is, because we have used an A tag, but A tag does not, have the same functionality as that of a button tag in HTML. So what this function will do is that by using this invoke function, it will actually invoke this input that we have. And as you can see, basically, this is where we'll actually upload our image. So the first function that we'll create, like a very simple function. Basically, the function name is invoke upload image, right? And what we're doing over here is we're going to be basically using the document dot get element by ID, right? We're basically calling this ID that we have in this particular or basically get element by ID, and we are calling this ID which we have. The ID specifically is the upload button. So we'll call this upload button over here. and what we'll do is we'll put the dot click. So basically what we'll do is we're invoking a clicking functionality to sort of mimic, like, functionality of let's say a button. So basically what we have done is that when this gets clicked, right, what it will do is that it will basically take us to this input function, and it will call in this upload image. This is the function that will be used to upload an actual image, right? So let's create another function now to basically upload our image, right? This is the most important step. So till now we have loaded our model into our JavaScript. We have basically invoked the upload command, and now we are basically creating this upload image functionality. This is where we'll be basically using our canvas, and we'll be basically loading our model to actually detect whatever image is being uploaded to its, right? So the first thing that we'll define is, let's define a canvas. A canvas is a space on an HTML where you can have like graphics, you can have images. So it's a very common HTML element that we have. So what we'll do is that we'll basically do something like document dot get element by ID again. So we'll be basically having our get element by ID, and we have already defined our HTML canvas over here, ID. So basically we can use this canvas ID, and simply what we have to do is this put this canvas ID over here. Wait. Now, what we need to do is that we need to actually set up like a context of our canvas. Basically, what we are doing is that we are drawing a file. We are drawing an image over the canvas. So basically, we have a function known as the get context that is used to get the drawing context on a canvas element that we make. This is thus being made to so that we can actually show case our image on this. So basically what we'll do is we'll use the get context function, right? Because again the function is canvas.get context, and since it's a 2D image, like basically the images that we'll be working on will be a 2D image, so we are using this 2D image. Right now the next thing that we'll do is we'll take the input, right? So let's say my input element, right, I'm defining an element that is the input element, and what I will put it is I will put it as document dot get basically document dot query selector. I'll use the document dot query selector, which is a JavaScript function, and basically what it will do is that it will input a file, because we are inputting a file. As you saw over here, we have an input tag, right, which we are basically using to input our file, right? So we'll be basically just using this input, and the file type that we'll define, for example, again, like what we have to do define is that the input that you're defining is actually a file. So we basically define the input as the type, and the type is the file, right? So we'll quickly just close this. Now, what we have done so far is that we have been successfully been able to generate a canvas and get an input element, right? Now, the next step is that what exactly happens is whenever you input something, there can be multi-input, but we just need the first element. And usually whenever you input something, it's like an array. So what we'll do is that we'll only take the first element, right? So I have basically this input element, and what we'll do is that basically since it has multiple files, I will only take the first element, the first element that I get, right? So basically that is why I've used var file equal to 0th position of the array, and that is the 0th position of the element. Now let's define an image, right? And what we'll do is that basically we'll just define this as document dot get element by ID, and we will define it with this image tag that we have, right? This image, this is where our actual image will actually land, right? So we can quickly just put in our image tag that we have defined. Now once we have basically defined our image, what we need next we need to do is that we need to actually see like what are the contents of the file, right? Because the file that we are uploading, we have to read that file, because by default it does not give us the permission to actually understand what kind of file are we uploading. So basically now we'll just use a function called the file reader. So the file reader is basically what it does is that it reads the contents of the file. So basically, the file reader will understand, okay, what are the contents. If in case it's an image, then we'll be good to go. In case it's not an image, we'll get an error that, hey, you did not upload the correct file type, because the file type that we need to upload is only going to be an image. Now, based on the image that we upload, like basically the file reader, we are adding an event listener. So basically an event listener, what it will do is that it will basically help us to load the image and then run a certain set of commands on that. So I'll quickly just put this event listener, and we'll wait for the image to actually load or the file to actually load. So basically we use the load, and then we'll basically run a function that will basically, what it will do is that it will compare whether the actual image that we have, like the file that we have, whether it is an image or not. So what we'll do is that we'll simply just do something like image.source, that is what is the source of the image, that will be reader.result, because what we're doing is that it is giving the image, like the image tag that we have, it is giving the result of whatever file that we are getting, right? So basically the reader.result will give it the output of whatever file type that we have uploaded, in this case it being an image, right? So now what we'll do is that we'll simply just put a set timeout function. A set timeout function is a JavaScript Windows function that basically executes some kind of a statement or some kind of function after a given time. So for example, in this case, we'll run this function after, let's say, 1 second. So I will quickly just define this function right over here. So what we are doing over here is that we can simply just, let's say in case you are uploading a very large image, I will quickly just run like a if statement that, for example, let's say if the image.height, basically I'm just scaling this image. Let's say if the image height is greater than 500 pixels, I will quickly just scale it to, let's say, the image height and width, right? Because since it's an image, we'll have its height and width characteristics. So I'll just use this image.height, and let's say I will multiply this by, let's say, 500 divided by image.height. So I'm just sort of quickly running this formula, and the image height will just remain that, we'll keep it as, let's say, 500. So I'm just scaling the image so that it fits onto the screen and it's readable. Now, the most important, as we saw in that code that we saw, we are going to be using the model.detect. This is where the model will now be able to detect the image, right? Because we have to run the model on the image itself, right? Then again, we'll be resulting that in a promise, and we'll be having a function where we basically get the predictions. Now, the predictions that we can get can be multiple. It can be single prediction. If there's a single object that is detected, it can be having an array of predictions, right? We'll be looking at how this predictions actually looks like the structure of how it actually looks like a bit later. But for now, we'll basically, what we'll do is that we'll, let's say, if it is able to detect an image, right? It will able to detect an image, and it is able to classify that object, right? For example, let's say if it's a classification as a human or a car, we have to draw a resultant image with the bounding box and a label. The bounding box, as I said, is basically it will create a rectangle in front of the object that is detected, and the label is the predicted value that it shows. So let's say for now, I create a function called, let's say, draw a resultant image, right? So let's say draw res. This is an image that will be made, and what we'll pass over here is the canvas, the canvas context, the actual image, and the predictions, because we want the predictions has the actual label, like the bounding box and the labels itself. So that is why it's really important that we create this function. So I will be defining this function a bit later, but these will be the parameters that will be used in the function. And I will quickly just close this and basically just let's see what else do we need. So we'll quickly just add the value also, because we are using the set timeout function. So I'll just add, let's say, 1000. This is 1000 milliseconds, and quickly just close this as well. And yeah, now the first thing that another thing that I just wanted to also bring up is that in case, for example, let's say if it is not able to detect, right? So what we'll do is that we'll just provide a false, because in case it does not actually provide us, we should be able to get, right? So I will just close this function. So once this is closed, the only thing that we are left is basically the file that we are uploading, right? So the file that we upload, basically whenever you're uploading, let's say, a new file, it should be able to clear your background that you have earlier, right? So I'll quickly put in an function like a if statement, and if your file actually does exist, what we'll do is that we'll clear out any kind of a rectangle that we might have drawn. So basically we have a canvas function called clear rect that usually clears out whatever canvas rectangle that we draw. Basically the bounding box is a rectangle. So what we'll do is that we'll replace it with the coordinates of 0, 0, and basically the ctx dot canvas dot width, basically the original width and the original height of the canvas, so that we are able to clear any existing image that we might be having. This is just to clear that. And again, to basically what we have to do is that what we can do is that we need to use the reader dot so there's a function called the reader dot read as data URL, which basically what it does is that as you can see, like this function, basically it will tell you that what type of file is it. Like for example, let's say if the file is of what size is it, basically it will tell you all of that. So this function basically will it sort of ends over here, and we can remove all of this. So this is the function that will be used to actually upload an image, right? So far what we've done is that we have basically like uploaded an image, and essentially the model.detect, what it does is that it will detect the image, right, the image that we have uploaded, and it will provide us the predictions. Now we can create this function that we have defined over here, that is the draw res, right? We will quickly just define this function, and it will take in all of these different parameters, right? The canvas, because it is a canvas on which we will draw the resultant image. The image that we have is and we'll be basically making the predictions on top of that. So we'll quickly define this draw res predictions function, and what we are going to be doing over here is that this function will be used to actually draw the actual image and the bounding box, right? So quickly, when we get started, let's say we define let's say our canvas, right? We define the canvas height and the canvas weight, right? So let's say the canvas height is equal to the image height, and similarly the canvas weight that we have, like the width, is equal to the image width, right? Let's define this. Now once we have defined the canvas height and canvas width, again we'll simply just what we'll do is that what we'll do is we'll run this canvas.rect clear rect, so that our if there is any existing rectangle that might be already existing, we can just sort of clear that out. Again, what we're just doing is that, and the next thing that we'll do is that we have to draw an image. Basically it will draw an image on top of the canvas, right? So in this case it is the image that we have, because we have to draw the bounding box on the input image. That is why we are basically giving it this, right? And again we'll just put in the height and width of the canvas that we have to draw basically this image over top of the canvas, right? Now the most important thing that we have to now do is that basically we need to define what is the font, right? What kind of font should we use to basically utilize to showcase our bounding box and the label that we draw. So for example, let's say I'll give it a very simple one. Let's say I give it sans serif, right? This is the font that we'll be using. Now let's say I also want to define what we can do is basically in the canvas that we basically have a function called the text baseline, right? So basically the text baseline will put where exactly should the text actually come up when you showcase your label, right? So let's say we put it at the top, right? Then what we can do is that we can now draw two boxes. So the two boxes, basically what we have to do is that we have to use two functions. Now the two functions, one would be to actually draw the bounding box, and the second is to actually draw the label, right? So for example, we'll quickly just define two functions over here. The first function would be, let's say, the draw box. This is to basically draw the bounding box, and this will take us this will take the predictions, and finally it will also take the font, right? So the font that we have defined. And similarly we'll be also defining like let's say the label, because we have to draw a label, right? So we'll define a function, let's say draw label, and this will also take the exact same parameters that are the canvas, the predictions that we get from our machine learning model, and the font, right? So we can ignore the font, right? So this is basically a baseline of what exactly we are looking at. So now the two functions that we need to draw, basically, I've already have the code for that. I will just quickly showcase because of the time limitation that we have. Basically, the two functions that we are drawing, and this is the most important aspect of it. I already have these two functions with me, so I will quickly just go through what exactly do they do. So the first function that we have is the draw b box, right? Basically the draw box. So what it is taking into account, basically it takes into account the canvas, right? Then what it does is it takes into account the predictions. Now basically the predictions, as I've said, it is essentially an array. The array would look something like this. The array, if I want to explain and how it is actually functioning. So basically the predictions is an array of an array. So basically it has an array of an object, the object being the bounding box. Now the bounding box is defined by 4 characteristics, basically the x coordinate and the y coordinate, and the basically the height and the width of the box itself. Like whenever it draws the box, it will basically give us a value of the x coordinate and the y coordinate and the height and width of the bounding box that we need to make. For example, as you saw in this scenario, the bounding box has 4 characteristics: the height, width, and the x and y coordinates, right? Similarly, we'll be having such multiple such values in case the predictions that we have are multiple. For example, if within an image we are able to detect 5 different objects, right? There is object detection going on. If we are able to detect 5 different types of objects, it will show us 5 different predictions. And apart from the predictions that we get, we also have basically the label that we get and the prediction value. Like what is the prediction value? So that is why what we do is that we define the x value as the first element, because that is the x coordinate. Similarly, the const y will give us the y coordinate of our bounding box. Similarly, the width will be the third element, because the third element corresponds to the width of our bounding box. And similarly, height would be the fourth element of our bounding box. So what we are doing is that now we are just basically using the stroke rectangle, which basically will draw out the rectangle, and finally we have the draw label. Finally, we have our draw label that will basically give us the predictions, and the predictions. Yeah. And finally, we'll be having our predictions that will give us the predictions on the bounding box, right? So the bounding box and basically the prediction.class, this function will basically give us what type of image it is, right? What type of class that it has detected. So with this, we should be good to go. And I'll save this function, and we will quickly jump on to our demo, right? So let's see if we are basically getting our, we'll quickly just I will quickly just refresh our page, and we should be good to go with the actual program itself. So let's see. We'll just wait for it to reload, and quickly we'll see if we are able to get the predictions and if we are able to show you a live demo. So let's wait. Probably it's taking a bit of time. Okay, so our model is ready. So as you can see, like the model it said was ready. We'll quickly upload an image. All right, the model is ready. We are good to go. And then let's say we upload an image of a car. It will take some time to load the image, and we should be able to see a bounding box being made once the model is actually loaded. All right, so as you can see, like it has loaded the car, but it hasn't drawn the label. So again, the reason for that is what we can do is that over here, we can simply just add, let's say in the draw label, where we have basically over here, we can probably also let's say we can set a few other things, like let's say the ctx dot stroke style. Basically, these are all different functions of and the stroke. Basically we have, let's say, as a stroke style, like what kind of style do we want, right? So let's say I give it the function of, let's say, the stroke style, we can give it, let's say 0 0. Again, like we have to basically define so let's say we give it 00f, right? After this has been defined, we can also, let's say, give it like what should be the width of the line, right? So we can give it like line width, and we can define the line width as, let's say 3. We can define it as 3. And finally, we have the ctx dot, we can give it like a fill style, like how should we actually fill it, right? So for example, again, we can simply just give it the same hashtag 00FFFF, right? So this should be good to go. And again, so what, again, just to sort of summarize what we have done so far is that initially we have loaded our model. We have basically invoked our upload function to upload our button, and we have used the upload image function to basically get the canvas that we have, and we have used the canvas to basically then also invoke our file, like the file that we have. Basically we input the file, and then we get we basically use the reader.add event listener to input our source, like the image source, as the result of the file that we upload, that is the image. And then basically we are using the model.detect, and specifically we are calling it in the image to actually detect our model object detection on the image that we upload, and then we get the predictions, right? So now then what we'll do is that we use this draw res to basically call this function that we have used over here, which will draw a resultant image, and it will basically create the bounding box on top of our model that we have used, right? So what we have defined over here is that basically we have defined the canvas height, canvas width, and we have basically called in these two functions, that is the draw label and the draw box, which basically takes into these particular values as you saw, right? So let's quickly save this and let's try to rerun our model. All right, so let's see. Okay, so it's giving me could not load content. Give me 1 second, probably. All right, so the model is now loaded. Let's try to upload an image now. Let's see what we get. Let's wait. All right, so let's see. I think that we are getting an error. We'll quickly see what is the error, that the font is not defined. Okay, so let's see. Quickly, I'll just check what is exactly up with the font. So over here, we had our font right over here. So what we can do is that, let's say we can define the font over here, and we can define this font as, let's say this part. We can do over here. Let's just define our font, for example, because it shows like the font was an error. So what we can do is that, let's say we define our font as const font, and then what we can do is basically just replace our font over here. Instead of this, we'll replace it with font. Let's see if this works out, and we'll refresh. All right, and let's wait for our machine learning model to load. That is the Coco SSD model. All right, so it has loaded. Now we'll quickly just click on the upload button, and let's see if it works this time. Again, fingers crossed. So this time we have selected the car, so we should basically get a label of a car. All right, so as you can see that we successfully were able to get a bounding box of a car. Now if I just show you the predictions that we get, as you can see, like in the 0th position that we get, we have a bounding box, and that's 4 values. It has the values of the x-axis, the y-axis, like the x-coordinate, y-coordinate, and the height and the width of the bounding box. It gives us the class, that is car, and that is what we are basically using over here. When we are drawing the label, we are filling the text as prediction.class, because it is giving us the prediction class as car, so it will basically print the car over here. And similarly, it also gives us a score. So basically, score is the prediction score, that how accurate, or basically what is the percentage of like prediction that, or what you can call is this, that 83% is the machine learning model comfortable that, or it's saying that it's 83% sure that the resultant image is that of a car. Let's say we upload another image, this time of a person. We should be getting a bounding box in front of the person with the person tag. So let's wait and let's see if we are able to get that. All right, so we were able to successfully get the person. As you can see that it creates a bounding box. It is able to detect that this object is a person, and it gives us the result as the bounding box. So this sort of comes up, sort of closes the demo. I'll be uploading this resultant code on the actual GitHub GitHub link. Again, I'll be sharing that in the Discord as well. In case you want to also reach out to me, you can reach out to me on these particular handles, that is on Twitter and LinkedIn. And with that, sort of brings an end to my demo as well, right? So again, in case you have any doubts, you can reach out to me and Jason. And Jason, probably, if you want, we can probably finish off, right? If you want to probably do that.
Oke, ini tadi ada yang tanya gitu ya, kenapa nggak pakai XAMPP? Kalau setahu aku ya, kalau untuk XAMPP itu kan buat database yang dataset kita bikin sendiri gitu ya. Kan itu pakai PHP MyAdmin gitu ya, kayak MySQL. Nah, kalau yang sekarang ini kan kita pakai web browser gitu. Jadi kan web browser biasanya itu download data dalam bentuk CSV atau JSON atau spreadsheet kayak gitu. Nah, kalau kita kan di sini kayak jadi klien gitu ya, di mana kita akses data orang lain. Jadi paling mentok tuh kita cuma dapat request data, habis itu kayak dapat bentuknya JSON atau CSV yang kita harus proses lagi gitu. Jadi kita nggak bisa kalau pakai yang kayak XAMPP gitu. Nah, kalau mau coba yang kayak XAMPP gitu, bisa coba diekspor sendiri pakai dataset yang udah dibuat sendiri kayak gitu. Kalau yang ini kira-kira udah pada ngelakuin to-do-nya belum ya kemarin? Untuk siapin. Oke, udah ya. Ada yang kebingungan nggak nih tentang yang untuk pakai web browser yang dari Chrome gitu? Ada yang bingung mungkin? Untuk yang ini? Gimana? Kira-kira ada yang bingung nggak ya ini? Jadi kita pilih foldernya. Mungkin ini mau pada ikut langsung coba, jadi aku kirim datasetnya di sini atau mungkin mau dilihat dulu aja gitu. Gimana nih? Ya, aku coba kirim ya sekalian datasetnya. Oke, sebentar. Aku lagi loading buat kirim ya. Oke, udah kekirim. Apakah udah pada dapat datasetnya? Bisa di-download kan? Kayak mungkin yang itu sama aku kasih dataset yang WDBC. Oke, udah ya. Jadi itu kayak dimasukin dulu di dalam folder. Terus nanti foldernya itu kita choose di sini, terus baru setelah kita choose foldernya, kita jalanin URL-nya gitu. Nah, Bentar, mungkin aku ganti share screen-nya biar sekalian bisa buka. Oke, udah pada download Visual Studio Code juga kan ya? Oke, bisa dibuka juga Visual Studio Code-nya, terus open file yang tadi, folder yang sama kayak yang tadi. Boleh kalau Sublime juga, kayaknya bisa ya Sublime. Oke, maaf barusan saya keluar dari Zoom karena nggak kuat sinyalnya. Oke. Tadi udah sampai yang tadi terakhir yang tanya Sublime gitu ya. Itu bisa kalau mau pakai Sublime atau Notepad+. Bentar, aku coba dulu buat buka lagi ininya ya, VS Code-nya, karena tadi sempat keluar dari VS Code-nya. Oke, semua udah pada bisa buka yang tadi kan ya? Termasuk yang tadi datasetnya udah pada bisa download kan? Oke, udah ya kalau datanya ya. Oke, karena tadi aku kan udah masukin di web browser yang tadi, aku udah pilih path-nya, mau buka folder yang apa, terus aku buka folder tadi week 1 gitu ya. Jadi yang keluar, nanti habis itu aku langsung klik web server URL-nya, terus akan ke direct ke sini gitu. Nah, untuk VS Code-nya, untuk lihat codingannya, masih loading buat bukanya sebentar. Kalau tadi kayak ini contoh kayak kita mau running first HTML cuman yang kayak biasa aja gitu. Kayak cuman ditulis aja my first HTML. Itu juga bisa. File first HTML-nya ini aku buat duluan gitu ya first HTML. Mungkin ini udah bisa buat share buat yang VS Code. Sebentar aku ganti layar. Oke. Oke, ini udah terlihat mungkin VS Code-nya. Nah, untuk yang my first HTML, kayak ini aku buat asynchronous function di sini to training, to model, const history, wait model.fit, xs, ys, epoch 500, callback on epoch n, ini asynchronous, epoch, log, epoch plus epoch, loss. Nah, habis itu ini untuk scriptnya. Terus untuk body-nya cuma keluar first HTML page. Ini masih loading terus ya. Nah, kayak gini ya body-nya. Oke, gimana cara aktifin web server ini? Oke, bikin folder dulu, terus nanti setelah udah download yang dari to-do kemarin, yang web server for Chrome ini, terus kita choose foldernya ini. Setelah kita choose folder, udah choose folder yang ini, select folder gitu. Klik satu, select folder. Nah, nanti langsung klik untuk yang web server URL ini. Nah, setelah diklik web server URL itu bakalan muncul di sini nanti. Nah, ini. Ini tadi ya tensor, bla bla bla, ini muncul dari yang atas ya. Ini tensor yang atas ini yang scriptnya. Gitu. Untuk coding yang first HTML-nya itu nanti lewat Visual Studio Code, jadi udah harus download Visual Studio Code juga. Bisa dikirim filenya. Aku kasih file yang ini ya, aku kirimin mungkin buat dicoba dulu bentar. Oke, ini aku kirimin buat yang first HTML-nya. Oke, ini berarti dimasukin ke folder yang tadi udah dibuat ya. Terus setelah itu bisa di running langsung, nanti keluarnya seperti ini. Tensor 18 ini oke. Terus kita coba yang iris classifier.html ya. Kalau ada yang nggak jalan itu boleh bilang di chat ya. Bentar. Aku open buat di tab baru aja sebentar. Ulang Kak, ulang yang bagian mana ini? Oke. Install Visual Studio Code lama nggak Pak? Nggak sih, setahu aku nggak lama. Terus kalau ulang mulai dari plot folder, oke kita ulang mulai dari plot folder habis ini. Ini setelah dia muncul tensor tuh gimana ya Kak? Itu berarti first HTML-nya udah bisa di running di web browser gitu. Ini cuma buat contoh awal kalau mau running ke web browser. Ya, aku ulang dulu buat yang tadi ya, buat oke, kan udah download nih yang kemarin web browser. Terus kan juga udah download Visual Studio Code. Nah, untuk yang web browser ini dibuka dulu di aplikasi yang Google. waktu kita buka dulu gitu. Jadi nanti ini ada di to-do ya. Ntar aku buka linknya kalau ada yang memang belum download juga mungkin. Ya, sepertinya kalau mau buka web server, running aja, nggak usah install Visual Studio Code. Ya, VS Code hanya buat text editor, bisa pakai Notepad+. Ya, betul, bisa macam-macam gitu. Kemarin kan juga udah sempet dikasih tahu ya di Google Classroom, aku sempat upload gitu ya, itu bisa pakai Notepad++, pakai Sublime. Kok nggak ada ya? Nah, yang ini. Nah, ini download yang ini dulu. Terus setelah udah di-download, bisa dibuka kayak gini. Terus kita choose folder. Di sini aku choose yang week 1, select folder. Nah, setelah di select folder itu diklik yang web server URL ini. Nah, kalau udah diklik, nanti dia bakal muncul kayak gini. Sebenarnya kalaupun nggak install si web server ini juga bisa jalan gitu, kayak langsung running dari lokal itu harusnya juga bisa. Kayak cuman dari sini, terus kita HTML-nya tuh yang kayak di open dari Google Chrome gitu tuh udah bisa sih harusnya. Nah, kalau di web server kan cuman buat ngeliat hasil dari code-nya gitu ya, hasil tampilannya. Kalau untuk ngodingnya, nanti mau baca codingannya lewat sini. Atau tadi benar bisa pakai Notepad++. Ini kita ke iris classifier. Ya, bisa. Kalau aku memang karena dari dulu lebih sering pakai yang ini ya, yang VS Code gitu. Kalau mau pakai XAMPP itu karena kalau XAMPP kan dataset yang kita bikin sendiri gitu. Kalau kita kan bertindak di sini kan kayak klien. Nah, kita pakai data orang. Jadi kenapa kita pakai URL nggak pakai XAMPP karena kita kan akses data dari orang gitu. Nah, web server kan pakainya akses datanya berupa CSV atau JSON gitu. Jadi nggak pakai XAMPP karena itu, tapi bisa juga sebenarnya pakai XAMPP kalau kita pakai dataset kita sendiri. Itu bisa dieksplor lagi nantinya. Oke, ini CSV URL itu iris.csv. Ini ya, iris.csv. Kita training data, TF data, CSV URL, is label true. True, habis itu di sini name of feature, training data column length min 1, name of sample 150. Iya, ini HTML. Kalau besok kita coba ke yang JavaScript gitu. Nah, kalau hari ini kita HTML. Besok Jumat kita JavaScript. Kalau yang main di JavaScript, Node.js pasti main di sini sih udah jago sih. Kalau kayak aku gitu, aku yang emang biasanya pakai Python, jarang sih pakai yang Node.js, HTML, ini jarang. Ini Species, Sentosa, Virginica, Versicolor, ini model TF Tire Dance, Moid, ini model definition, sequential, Moid, add, softmax, categorical consent topi, Adam 0,06, ini learning rate ya. White model fit dataset, report 100, callback, console. Oke, kita sambil running ya ini. Ini lumayan lama nanti. Oke, kelas name-nya Sentosa, Virginica, Versicolor. Nah, ini ya, Iris Classifier, run script with Chrome web browser, open developer tool. Ini bodinya. Yang tampil yang tadi scriptnya ya. Oke. Oke, masih loading. Ini alertnya nggak mau keluar sini barusan. Bentar kita coba ulang. Inspect console. Bentar. Inspect console. Ya, ini mau. Ini kan nggak mau ya. Oke, HTTP response. Aku ada salah pet kah? Sebentar. Oke lah. Kalau gitu ini nggak bisa ya. Tadi kayaknya ada error karena HTTP response code failure. Itu mungkin kemungkinan besar aku ada salah di pad-nya. Kemungkinan besar aku ada salah nulis pad-nya. Tapi nanti coba dilihat lagi ya, disesuaikan juga sama pad kalian. Gitu. Iya, kayaknya ya ini kayaknya karena salah pad-nya ini. Oke, aku save. Kita ulang. Parameter lang di tag script. Ini kan JavaScript itu kan JS. Nah, kalau yang langnya itu kayaknya nggak masalah sih, karena yang pertama pun nggak masalah gitu, yang first HTML. Kayaknya emang aku tuh ada salah masukin pad-nya gitu. Ada error di pas masukin pad-nya. Kalau yang ini aman sih, yang terakhir. Oke, ini aku harus open cam. Ntar nyari. Oke, ini bisa. Oke, rock, paper, scissors. Kita mulai dari yang rock dulu ya. Kayaknya nggak boleh kelihatan mukanya sih harusnya. Ini rock. Paper. Nggak mau ya kawan. Harusnya sih ini jalan sih. Masukin semua contohnya dulu satu-satu. Kita inspect. Ini Oke, nambah nih ya, nambah ya sampelnya. Habis itu paper juga nambah ya tadi. Scissor. Oke, Spock itu kayak apa ya? Aku lupa nih jadian Spock. Ntar ada yang ingat nggak nih? Spock kayak apa nih? Sama lizard. Ntar aku jadi lupa deh. Tangan terus tengahnya buka. Gini nggak sih? Yang gimana ya, Spock? Iya kan? Hah? Gitu. Oke, Spock. Gini ya? Kayaknya gini ya? Ya, betul. Bentar, kita arahin dulu. Kita kasih yang Spock ya. Oh, oke. Gini. Oke. Ini. Kalau lizard yang kayak gimana nih? Kayak boneka ngomong. Kayak gimana? Kayak gimana? Gini. Oke, gimana kalau yang lizard? Oke, gini. Aku lupa beneran deh. Aku terakhir kali buka project yang ini tahun lalu gitu. Gini. Boleh dong ada yang open mic 1 gitu, request. Kayak ular mangap. Gini. Tapi dia bukannya harus kelihatan yang gininya ya. Iya, banyak salahnya jadi bingung. Gini ya. Kita coba gini ya. Berarti nanti aku tanya lizard gini ya. Oke, kita coba segitu ya. Kita train. Kalau mau nyoba harus yang banyak sini kayaknya. Oke, kita train. Oke, trainingnya selesai ya. Kita coba mulai buat start predicting. Oke, start predicting. Udah bisa belum ya ini? Oke, masih belum jalan kayaknya yang prediknya. Once training is completed, click. Harusnya sih mau nanti kalau gini tuh kayak real time langsung keluar gitu nanti namanya itu apa gitu. Oke, nggak mungkin kita coba ulang ya yang ini ya. Aku pengen nge-reload buat ngeliat lagi itu beneran jalan nggak gitu. Tapi kayaknya nggak mungkin kita coba ulang. Oke lah kalau gitu. Yang ini kita biarin aja ya. Harusnya ini kan training udah done nih 2 kali nih dia udah keluarin dan kita coba ya lanjut start. Ayo bisa dong. Iya, antara ngehang atau proses gitu. Oke, ayo bisa dong. Lost. Oh iya, bisa IC paper tuh. Rock, paper. Kok jadi lizard ya, kita coba lizard. Tuh, bisa tuh IC lizard. Slok ya. Gini. Gak mau dia yang spok, kurang nih kayaknya datanya yang spok. Rock, paper, rock. Scissornya nggak mau. Lizardnya mau. Tadi mau loh lizard. Ayo. Ayo wizard. Nah ini lizardnya mau. Oke, lizard kadang kebaca rock ya gara-gara. Oke. Berarti yang nggak mau itu si scissor sama si spock. Kurang datanya ini yang spok. Nah ini nanti bisa dicoba-coba ya. Seru ya main kayak gini. Kalau paper gampang ya. Paper, rock. Tapi kok scissor nggak mau ya malah. Itu mau tadi. Nah. Oke, sissernya mau. Sissernya mau. Kenapa Isa kadang ngebaca paper ya? Iya, masih susah bedain scissor sama rock karena mungkin posisi tangan aku kan tiga-tiganya kan ngepel ya kayak gini ya. Jadi kan bedanya gitu. Gini sama gini. Ya, kalau gini ya, itu nanti dicoba-coba ya. Boleh dicoba-coba satu nanti. Gitu. Coba kepala tangannya diumpetin ke bawah. Diumpetin gini. Susah, nggak bisa. Nggak mau deh kayaknya. Tapi yang lizard tadi mau sih, lizard. Nih, lizard. Oke, seru ya kayak gini ya mainnya ya. Ini nanti boleh dicoba-coba ya. Seru kan? Ini loss-nya lumayan nih ternyata. Kecil banget nih yang akhir loss-nya. Harusnya kita nambahin ya. Nah ini kenapa nggak boleh sampai kelihatan mukanya waktu lagi nge-foto awal. Karena ikut kebaca. Harusnya kita coba tambahin datanya deh. Iya, susah bedain. Oke, tadi yang Spock juga yang susah ya. Oke. Kok kesisir? Kesisir. Salah klik. Oke. Kita, ya udah gitulah ya. Jadi mau sih. Harusnya mau ya. Harusnya itu benar-benar dari setiap sudut pandang gitu. Kayak yang kemarin waktu rock paper scissors itu. Oke, kalau yang rock sama paper gampang ya, dia cuman gini aja udah kebaca. Padahal sampelnya dikit yang rock sama paper. Lizard. Oke. Kalau mau modelnya ke save, harus di-download modelnya nih. Oke, kita train ulang ya. Kita stop predicting. Oke, ini lagi loading ini pasti. Oke, training dan oke, kita start lagi predictingnya. Ya, yang ini lumayan seru ya. Oke, dia belum mau berubah sih. Masih nungguin. Oke, masih nunggu. Kayaknya ini masih loading buat predicting. Nah, ini udah jalan ya. Oke, kita lihat. Oke. Oh, ini pasti karena tangannya itu kayak ada selanya, jadi dia kebaca yang Spock tadi. Oke. Lizard, bedrock, scissor, pepper. Kenapa dia masih pepper, rock? Oke, udah bisa semua ya ini. Kayaknya karena sekarang kebanyakan yang Spock deh. Jadi kalau aku bikin yang kayak gini, dia karena ada sela-selanya ini, jadi kayak gitu deh. Ini karena banyak sela-selanya, jadi kayak kalau dia baca sela yang ada selanya itu kayak jadi Spock tuh. Nah, tuh. Karena kan Spock ada selanya nih. Gitu. Ini nanti coba-coba lagi aja nggak apa-apa ya. Nanti aku coba kasih ininya code-nya. Ini code yang ini. Rock, paper, scissor, lizard, Spock. Kayak ini. Oke. Oke, yang ini kayak gini ya. Berarti dia yang terakhir tadi setelah ditambah, tapi yang rock sama paper nggak aku tambah, ternyata papernya jadi error ya, malah. Kalau kadang papernya tuh jadi kebaca si Spock. Nih, Spock padahal paper. Ini loss-nya 0,0016. Kalau yang sebelumnya tadi berhenti di loss 0,00125 nih. Yang tadi sebelumnya ini ya. Oke. Sampai di sini mungkin ada yang mau tanya. Kita udah jam 21.55. Kalau mau selesai ini, kita download modelnya ini baru nanti ke save modelnya. Berarti metric loss belum cukup menunjukkan model itu bagus atau tidak ya? Belum tentu sih, karena kan tadi ini ya, kalau misal backgroundku kosong, terus habis itu nggak kelihatan juga pundak sebelah gitu, terus benar-benar aku foto cuman tangan aja, mungkin hasilnya bagus. Kalau secara logika semakin banyak tuh model loss-nya kecil apa besar? Besar. Ini tadi dari yang satu, harusnya sih kalau modelnya benar-benar udah banyak, terus dari segala sisi yang kayak, misal kalau kita main kan, gini, itu dari samping gini pun ketahuan, dari gini ketahuan, dari semua, pokoknya dari semua sudut pandang tuh kelihatan itu, harusnya loss-nya kecil sih. Kayak kalau mau tuh kayak yang kemarin di kelas yang apa ya, CNN kalau nggak salah, iya CNN, yang background-nya hijau terus gambar tangan yang rock paper scissors. Nah, kayak gitu sih contoh buat ngefotonya. Kalau nambah model lain, iya tinggal nambah aja di sini. Nih, tambahin aja ID-nya apa, terus misalnya kita tambahin ya. Kita mau tambah apa nih? Nanti tambah button, terus ID buttonnya berapa, habis itu. Terus datasetnya, buat datasetnya harus datasetnya aman, nggak perlu ditambah. Nah, yang tambah ini cache 3, berarti kalau mau nambah lagi, ditambah cache yang 5 tadi. Cache 5 apa gitu. Kayak gitu. Nah, ini udah sampai cache 4 yang lizard. Oke, yang ini lumayan seru ya, contoh codingnya ya. Oke, ini kita udah jam 21.58, aku tunggu mungkin sampai jam 22.00 pas ya. Kalau masih ada yang mau tanya. Kalau nanti mau coba ini, kalau bisa itu kayak diarahin ke tembok gitu, yang background-nya tuh putih, terus kita cuma dari samping ngeliat kliknya aja, terus cuma tangannya aja gitu yang dipasin. Jadi biar benar-benar hasilnya tuh bagus gitu. Oke. Nanti dicoba ya. Kalau nanti aku bagiin code-nya, dicoba. Mungkin kalau mau ada yang nambah gitu, bisa ditambah. Ya, coding sendiri ribet. Kalau ini banyak nonton-nonton kayak ikut-ikut course, habis itu tahu cara-caranya dulu bikin awal, terus tahu dari awal kayak apa gitu. Nah, kalau yang tadi yang error, itu aku kayaknya beneran salah pad-nya sih. Nanti coba disesuaiin sama pad-nya ya. Nanti aku pengen sih bagi code yang ini, tapi aku nanti omong dulu ya sama instruktur yang lain gitu. Kalau enggak kan tadi aku udah share ya, aku udah sempet turunin pelan-pelan gitu, biar bisa diikutin. Nanti jadi bisa diikutin dari sini. Aku belum tanya sih sama instruktur yang lain, yang ini boleh di-share enggak? Gitu. Terus untuk tugas minggu ini cukup nggak kayak biasanya ya, kayak kita nggak coding tugas minggu ini. Jadi tugas minggu ini cuman bikin ringkasan. Nanti aku kasih linknya buat link yang mau diringkas itu apa. Sebenarnya kalau ini dibagi jadi PR tuh yang your code here ini mau dihapus-hapus gitu loh. Tapi kasihan kalau buat jadi PR gitu. Awalnya kalau ini mau jadi PR yang your code here ini tuh kita potong di bawahnya ini kita hapus. Kita hapus terus jadi assignment kalian gitu. Kita hapus. Kalau ganti tangan kanan menurut try lagi, ayo kita coba. Oke, kayaknya perlu di-train ulang kalau ganti tangan. Nggak semua mau kebaca kalau ganti tangan, kayak kalau yang ini udah mau kebaca semua. Ya, bisa banyak cara. Jadi bisa banyak, nanti dicoba-coba ya. Oke. Ada lagi mungkin yang mau tanya? Ya. Ini JavaScript semua. Besok kalau kelas hari Jumat bakalan seru sih, karena ngeliat langsung yang JavaScript yang udah jadi itu kayak apa. Ada yang bentuknya 3D langsung di layar gitu. Project-project yang udah jadi keren-keren. Ada yang kayak game gitu. Ada yang bisa ngikutin gerakan tangan, jadi nanti setiap ini tuh ada titiknya. Jadi kalau kita gerak gini tuh kelihatan gitu. Oke. Mungkin ada lagi. Udah ada lagi yang mau tanya mungkin? Untuk PR-nya nanti aku share langsung ya di Google Classroom, jadi dikumpulnya besok Selasa. Oke, kalau nggak ada yang tanya, aku stop share. Oke, aku stop share dulu. Oke. Ntar aku ganti kamera dulu. Aku close dulu yang tadi ya. Ntar. Oke. Yang bisa open cam boleh open cam ya. Oke, kita mulai dari layar pertama. Oke, layar kedua, layar ketiga. Oke. Baik, terima kasih semuanya yang udah hadir pada kelas hari ini. Nanti mungkin kalau mau coba bisa ditonton ulang videonya, terus dicek codingannya lagi, terus dicoba-coba sendiri gitu ya, dieksplor lagi. Oke, makasih semuanya. Selamat malam.